Next, I'll modify a question just a little and check if you've absorbed our line of reasoning. I ask you, what's the probability that a female picked at random from this dataset makes over 50K? Don't worry, I'll even put up the pivot table for you. Just pause the video so you can carry out a quick calculation. And don't worry if you got everything wrong. The idea is for you to check how far you can reach in your arguments. I hope you really took the time off. Here's how I would go about formulating an answer. First, I'll extract information about the event from the statement of the question. Our event is that of a chosen female making over 50K. Let's look at the pivot table over here. The female row is the very first one, and I get 1112 outcomes or females in favor of this event. That's our numerator. Next, we decide what the sample space is. Remember, we are only considering females in our data set. So, if I were to look closely, there are 9,781 of them, and that's the denominator. We now obtain the probability as 1112 over 9781, which amounts to approximately 0.114 or an 11.4% likelihood. Roughly speaking, 1 in 9 women within our dataset make over 50K. Compare this with the earlier figure of 1 in 4 persons making such high salaries. We had left out the gender, mind you. So there's a huge discrepancy. We could bring in an extra variable of education level into the picture. However, the complete answer to this conundrum might require us to go beyond our data set. And I consider that out of the scope of this discussion. In this segment, we laid out the framework of probability and derived answers to a few of our questions. Our elaborate approach might appear like much ado about nothing to some of you out there. But you wouldn't walk into a boardroom and declare, I think we should increase our advertising budget by 13% and just walk away. You'll have to justify that number. So if you do things systematically, you won the war.
In all probability, that is.
Okay, we'll catch you later.